Greetings to you all, ladies and gentlemen. It's Wandile here, the leader of Manekwet School, which is a school that is dedicated to programming problem-solving skills. And today we're going to be working on exercise 1.7 of this textbook over here. This is the textbook we're using, right? So in case you haven't yet got yourself a copy, I am going to leave a link below so that you guys get your own. Okay, so where is the question? Here's the question. It's actually exercise 1.7. What they're telling us to do is to approximate pi. So pi can be computed using the following formula. So we are asked to write a program that displays the results of this and the results of that. We're gonna use 1.0 instead of 1 in your program. It's better to know why they even say that. Why are they asking us to use 1.0 instead of 1? By the way, I've already created this exercise called exercise 1.7b. And as I've just said, some of the solutions won't have 3 solutions. Some of the problems won't have 3 solutions. The reason being, some problems are pretty straightforward, so there's no need to waste time and energy, because the only way I can possibly have multiple solutions out of this problem is to keep playing around with the print and print clean methods, of which you guys well understand by now, so I don't see the point. So let's get on to it. So let's do the first step. Step 1. What you're gonna do, we're gonna have to compute we're gonna have to compute 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9. Or lastly, minus 1/11. Let's check if I wrote that down the way I'm supposed to. Sure, I did. This is the very first thing we have got to do. And the second step is to multiply the results by 4. So basically this is what we're gonna have. Stem.out.println. We're gonna have 4 multiplied by this whole thing. Let's try to run this. Look at this. This is incorrect, you guys. Reason being, we used 1 instead of 1.0. As we were told, we gotta do what we were told. But you gotta know the reason behind why do we need to use 1 and not 1 point. Why do we need to use 1.0 and not 1? The reason is straightforward. You see, look at this. You see these fractions, 1/2, 1/5, 1/7, so on and so forth. These fractions are made up of integers. 1 is an integer and 3 is an integer too. So the compiler treats this, since this is an integer over an integer, it also treats the results of that, the answer to that, as an integer. So 1 divided by 3 is not 0.00000. It's not, oh my god, it's not 0.333. Instead, it's 0 because 3 cannot go into 1. The very same thing applies here. This is supposed to be 0.2, but because these are both integers, 1 and 5, the whole thing is treated as the results of the whole thing is treated as an integer, which is 0 instead of 0.2. I think you guys are clear with that. So let's solve that out right now. We gotta put 0.1, we put 0.1, we also put 0.1 here, and 0.1 again. Now let's see what we get. You see, now we get something different. Okay, for readability, let me do this. Again, you guys, we were not asked to put this, but I am gonna put it though so that you guys will be able to read this properly. Simple solution. Let's just go system.out.print lin. Let me just go better solution. Look at this before I proceed. You see, this text here, better solution, doesn't look okay with its being way too close to this number here. So in order to avoid that, let's put a \n before printing the word. That is to say, we're going to go to the next line before printing the word better solution. Okay, a better solution will then look as follows. It's going to look as follows. Out the print lin. It just go first approximation of pi is can copy and paste this. Let's put it inside the brackets, and do this. Notes though, let's try to print it out. You see, this is more descriptive, unlike the very first one, because like who knows what number does this, what is it does this number present? So it's better to make it descriptive the way we did on the better solution. So first approximation of pi is that. Oh, I almost forgot that we're supposed to have two approximations. Here though we gotta add 1 over 13 if I'm not mistaken. Let's check it out first. Yeah, 1 over 13. It's 1.0. Okay. Okay. This is our second approximation, but we gotta add. We've got to add 1.13 plus 1.0 over 13. Let's run it again. Oh, let's put second because this is actually our second approximation. You see, this number here is actually getting closer to the true value of pi. Basically, the idea is the more you add on this formula, the more you add numbers, the more you add fractions following this pairing though, the more you approach to the true value of pi. Let me do this. Here, let me just go system.out print ln, and then before I print anything, let me go to the next line first and then say the actual pi value is math.pi. What is math.pi? Math.pi is nothing else but a constant that is defined within the math class. So whenever you want to work with pi, you don't want to keep using the approximated value. You gotta use the exact value of pi, which is math.pi. As I mentioned before, whenever you want to work with math functions, mathematical equations, so on and so forth, you gotta check out the math class. So let's see what we have now. Again, you see this number here is not closer to the true value of pi compared to this number here. So as I just mentioned, the more you add those fractions following that pairing, the more you're going to be approaching this number here. Okay, that was pretty much it. It was such a long video, you guys. Let's wrap it up now. See you on the next tutorial. Cheers.